Hello, technicians, and welcome back to another episode of the Life Safety Troubleshooter. My name's Gary, and let's go ahead and get into it. I first want to address a couple comments that were made. One person had indicated they didn't understand why ohms was so evil, that it was going to lead you astray and you weren't going to get good readings on it. Well, remember, we work on fire alarm systems with literally thousands of feet of wire. So it's going to pick up every capacitance, inductance, RF, and it's just going to mess things up. So the reason you don't want to use ohms is very simple. And I'm going to show you this. I'm going to show you this meter here. So here's the meter. And you can see that the meter on the left is set for ohms. The meter on the right is set for milliamps, or microamps actually. And you'll notice it's only reading about 304 microamps. So it's not using a whole lot of power to get out there. So voltage 2 is an issue. So let me go ahead and switch this over to voltage so you can see how many volts it uses. Because remember, technicians, voltage is pressure. And I was taught when I was in the Navy that you equate voltage like you do a water pipe. So an ohm meter, in my estimation, is basically a little 1/8 inch or so pipe water that you use on a windshield washer on your car. That's how much pressure that this ohm meter puts out. So, having said that, using an ohm meter is like using a windshield washer pump. Now, I was also told that they've had a lot, one technician had a lot of luck using a toner battery. So, here's a toner battery. I realize this toner is old, but they're pretty close to what the modern day ones are. So, as you can see, this one is reading about 18.7 milliamps, which is pretty good. That's a nice amount of current for what you're doing. Now let's go ahead and switch it over to volts and see how much voltage it's putting out. And there we go. Battery's a little weak, so it's putting out 8.7, about 8.7 volts. So that's better. That's a whole lot better than an ohm meter. I would equate it to, say, a garden hose. So now you've gone from a windshield washer pump to a garden hose. Now you go to my Cobb Boxx. And that being 24 volts and 100 milliamps, now you got a lot more pressure at 24 volts. And of course, the reason I use 24 volts approximately, it's a little bit more, because there's 3 9-volt batteries in series, is that it more closely emulates a fire alarm panel. Now, a fire alarm panel, when it uses a ground fault circuit, you got to remember that it is designed in a way as to not crash the panel. So it doesn't take much current to cause a ground fault. If you can find the ground reference on a ground fault circuit, which is pretty easy on some panels, not so much on others, usually it's one of the screws that you can take loose and you put a credit card or a plastic credit card or fold it in half business card back there. You can get in series with it, and you could actually get in series with a ground fault circuit, which is really cool. And you do that with microamps normally because that's all it's using to find this ground. So you can do it that way. So having said that, any more questions you might have about ground faults using the Cobb Boxx versus a toner versus an ohm meter, let me know. I will answer those questions to the best of my ability. So, now that I've gone through that, I would like to go through one of the most difficult problems I have ever encountered finding a problem, and that is invalid replies with no set pattern on an addressable system. And this one was rather weird. First, you need to understand how an SLC works. So I'm going to show you this picture here. And this is a picture basically of an oscilloscope reading, a still picture of an oscilloscope reading an SLC loop. Now, don't pay attention to the values on the left. They're not very accurate as far as knowing what's what here. But I want you to consider down at the bottom where the lowest point is, that's 0. The next highest is about 5 volts. And then, of course, the top is 24 volts. So an SLC loop basically uses those 3 reference points to communicate. So 0, 5, and 24. Now, if you have a tone pickup, you'll hear it. You'll hear it kind of trilling. I call it sometimes trilling. I can somewhat duplicate it. It kind of goes. I know, sounds funny. You're probably laughing, but hey, that's the way it sounds to me. So you hear this thing go off, and what you're hearing is this digital signal, 0, 5, and 24 volts. So if you take your voltmeter across here, and you'll notice at the top I've got 13.83 volts. Now remember, this is a still picture. In actual real life, you put your DC voltmeter across this thing, you are going to read fluctuating voltage within a particular bandwidth. So it may fluctuate low as 12, as high as maybe 14, 15 volts tops, and that's going to be normal. Now, what this problem does is really, really bizarre. So here's another picture, and this picture is of an SLC circuit on an oscilloscope. If you look, you'll notice it never drops to 0. Why? I can't tell you. What caused it was a addressable relay. So you can see this where it's going 524, 524, and you'll also notice that the voltage went up to about 16.5 volts. So what tells you you have this particular problem if you don't have an oscilloscope is you will see the average voltage jump up by a couple of volts. Now, the way I noticed this is, number one, I had the oscilloscope on it, but people, technicians, just try and stare at something for a minute or 2 minutes. I mean, I wasn't ready to do that. So I took my beat box, put it on the circuit, adjusted it so it was kind of like a whisper. You could hear the trilling noise. And I sat there and I waited, and all of a sudden, the trilling stopped. I went, wow. So I looked at the oscilloscope, saw this, and went, oh boy, now why the heck did it do this? It was obviously a WTF moment. I've never seen this before. I've seen it very infrequently, but when this kind of a problem happens, it's a real pain to find. So once I identified what was going on, and that's very important that you identify the problem. Never assume what's going on. Identify what is going on. What is causing your system to do what it is doing? So I identified the problem. This is what happened. It was stripping the 0 reference out. It was only doing 5 and 24. Had no clue why, to be honest with you, technicians. I still have no idea why it did it. Maybe the manufacturers can tell you or give you insight into it, but it was a real pain. So the way I found this is I had been there for about a month, off and on. I had a half a dozen recording meters on it because I thought it was a power problem where it was crashing the SLC loop and it was sucking too much current. Well, I was seeing some odd readings, but I never really saw the current spike and crash the SLC. So the way I ended up finding this, I had been there so often that I went to the farthest point of the system, disconnected it. Fortunately, it stayed for a bit. Disconnected it, didn't go away. Came back, disconnected, didn't go away. Came back, disconnected it, went away. Fortunately, it happened to go away down a particular run that only had one relay on it. So I went ahead and checked, reconnected it. Fortunately, it was pretty much staying in a problem. Disconnected the relay, put the circuit back together. Everything was great, stayed great for about 5 minutes. I replaced the relay, fixed the problem, addressable relay. But I still to this day don't know why it did this. I just know it did. It's not as easy to find as a current problem where you could actually see the current spike either on a graph meter or even sometimes on a normal multimeter. But this is a hard one, and this is the only way you can troubleshoot this is first identify it. So if you've got invalid replies coming in and your current's not spiking, you need to check your voltage. If you got an oscilloscope, they're not as expensive as they used to be out there. This oscilloscope, I think, cost me a couple $100, and I had it tied into my computer, and that is what I got. So that's the invalid replies with no set patterns, the two causes I'm aware of, which is the current draw and the stripping of the zero reference on the oscilloscope. The next thing I'd like to go over in this video is opens and shorts. Now, when I first started in this business, I started in the burglar alarm when it was 19 twist wire. One cable went all the way around the premises and everything was tied to one cable. It was foil. It was photoelectric eyes that used incandescent bulbs. Sometimes it was actually photoelectric smoke that used incandescent bulbs. It's crazy because the old incandescent smokes would draw about 250 milliamps, a quarter amp. So sometimes these power supplies would be pretty big. Anyway, I used to run into problems with intermittent foils, intermittent connections, bad switches, intermittent switches, because some of the switches, like the older switches, they were also mechanical. So you could actually hear these things thunk as you would put the magnet to it. But this is what I did. Out of necessity comes invention. So my first invention, my first tester out there, was a very simple tester using a 9-volt DC double pole, double throw relay with an impedance that drew about 10 to 20 milliamps. Depends on what kind of 9-volt DC relay you got, what the impedance of the coil was. In the old days, we used to have what were called 1,000-ohm relays. You put 3 volts to it, it would draw 3 mils, and it would actually close the relay. Well, I never have found a 1,000-ohm relay anymore. I mean, I might have one somewhere because we used to scavenge them because they were so easy to use. They would work on multiple voltages. Anyway, so here's the relay. And I'd hook this relay up, and if you look at the wiring, I'll explain to you how this works real quick. So you were looking for, on a closed circuit, an intermittent open, you would hook these leads, and you see how it goes over to here. So you'd switch this over to these leads, and you'd go out, and this was a double pull, double throw relay. And then you'd press this button. When you press this button, you were closing the circuit here to the coil. This would come down. The coil would be connected to positive, and all would be good. This sounder would stop sounding. So you were ready to go. Now, the response on this was pretty good, 50 to 100 milliseconds, because as soon as you broke that circuit, even if it was for a moment, even if it was only for 50, 250 milliseconds, whatever it was, this relay would drop out. This would cause the sounder to go off. Oh boy, I found it. The big drawback to this is it was not self-resetting. So every time this thing went off, you had to go back, press the switch again, and reset it. And sometimes if you press the switch and it wouldn't reset, oh, I'm open, I have to revert back to my meter. So that was all well and good. I was finding intermittent opens on foils and mechanical contacts and all kinds of different things. Then I wanted to find intermittent shorts. So I added a single pole, single throw switch here to basically short this out. Flip this double pull, double throw so the circuit went up to this button. So now it would be energized all the time. I would flip this switch so that that would only beep when I did get a short, which would latch. And I would go out there and see if I could find a short. And if I did find a short, if I intermittently shorted it. Now remember, this is mechanical. This is a relay. It's not going to have a 50 millisecond response on a short. Not even probably a 200 millisecond response. It's probably closer to about 500 milliseconds to 750 milliseconds. But at least it would tell me if there was a short and it would latch. So if I got a short on there long enough, the sounder would go off. So then I'm like, wow, this is really a pain in the butt having to move this thing downstream on the circuit. Got to be a better way. So then I advanced from there, made the sounder a relay, bought myself a pair of very cheap walkie-talkies, basically took them apart, soldered a normally open connection across the call button on these cheap little toy walkie-talkies. And then since that was now a relay instead of a sounder, I then took this over to the walkie-talkie. So now, if my circuit opened, and if I was using it in that way, it would cause the walkie-talkie to sound. I'd have to go back to the unit still and press the reset button. And if it shorted, I would still have to go back and open this switch up here momentarily to unlatch the relay. But at least I was getting a little bit of distance on that. Now, the tester I have now is the Cobb Boxx, and it's electronic, so it's got a lot better response time, both on open and short. And the memory is self-resetting. And I'm still working on getting the patent for it. I really want to get it out there because it's a really great tester. I have found so many intermittent grounds on that. I have found grounds where I've taken a 24-foot pole, basically painter's pole, and went around pulling on cables, and it found basically intermittent grounds on cables that were 20 feet in the air, 18 feet in the air. Because I'll use that pole and I'll very gently, and that's the key factor, gently tug on the wiring because you want to elicit the ground, not get rid of it by tugging on the wire. So I've done that, and I've tapped on things, I've moved wiring around, and boom, it will go off. If I hit it intermittently, it will pulse beep a few times, and then it'll stop as long as the intermittent short is just went pop and then released. Same thing with an intermittent open. I could do the same thing with an intermittent open. For some of you older technicians out there, we all know that the old Edwards, I think they were 650 smoke detectors, used to have a problem on the bases with bad solder joints because they used a little bit too much lead in their solder. And it would crack around the pin. So you'd get this intermittent open out there, and it would drive you crazy. Customers would say, well, this thing goes open, 10 times a day. I need you to fix it. Well, I would find those basically by putting my tester on it and reading the end-of-line resistor, trimming it out with a potentiometer, and I basically would go down the hallway and tap on these smoke detectors. And when I got to a smoke detector that had a bad connection on it because of the cracked solder around the pin, as soon as I popped it, it beep, 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 and it would reset because it wouldn't stay open. Now, if it happened to stay open, then the tone would go solid. So this was the first stage. This was the first stage of it. I wasn't satisfied with it. I made an electronic one out of different, back then, transistors, resistors, and a chip. And I designed it and made it, and I was pretty much one of the only people out there that had it. I did have a couple of other technicians that I worked for that had it because I gave them the schematic for it. But now I want to commercialize it. So I'm hoping to get it out there for you in the near future. I think you will find it's a good tool because I have designed it to integrate with most walkie-talkies with a Boxx. So that's a big help. Anyway, that's my original one. Simple 9-volt relay. Sorry I haven't gotten back to you as soon as I could because we've had a lot of wind down here in southeast Missouri. So we've been dealing with some of the aftermath. So I'll try and get another video out there next week because I want to go over other things like troubleshooting circuits for bell circuits, how to check batteries properly when you don't have a battery tester, and many other issues. So if you have any problems out there that you would like to discuss or get my advice on, I may have seen it. I've seen quite a bit in 41 years. I will do the best I can to answer some of your questions. Again, like, subscribe, and share this video. I think this is going to be a good video for a lot of the new technicians, a lot of the older technicians. You may have a better way of doing things. And even though I've been in the business many, many years, you could always learn new techniques that work a little bit better. And sometimes old techniques work better. So again, thank you for watching. I will try and get another video out next week to discuss some more points. I will be looking for those comments. A little new to this, so have patience and try and answer some of those questions for you. Thank you for watching.